Welcome back to another video. In this video, I want to take you through this snake-like game that I've built using JavaScript, and more precisely, JavaScript in functional style, or in functional programming style. So with a focus on purity, small functions, and composability. So as you can see here now, I'm running this snake game in the browser. And you can see also there that I actually crashed. Sorry, my camera is in the way, so I can't really see what I'm doing in this snake game. So, but this is the browser implementation. And because I tried to put the focus on modularity, it was kind of trivial to make one sort of GUI for the browser and then another GUI for the terminal. So if we jump over here to this side, you can see if I just look at where I'm at now, I'm in a folder called Snake where I have a few files. And what we're looking at here in the browser is this web.html file. But what I can also do is I can run this CLI.js file through Node, and then we can play Snake in the terminal. So if we run CLI through Node, you can see that we now get Snake, but in sort of terminal mode. Let me make this a bit bigger. So the X's represent the snakes, the dots are the grid that's traversable, and the O's are the apples that you need to eat in order to become longer. And the interesting portion is, of course, or the interesting part is, of course, that this runs on the same quotation marks engine. Like we've separated the game engine from the visuals of the game, which is generally what we should do, right? We should separate presentation from the business logic. So my interpretation of most of these Snake tutorials, or actually game tutorials that you find on the interwebs, is that they are focused on just getting a quick version up and running quickly, essentially. But what I want to do, as I tend to do with all of these videos, is instead talk about design. So I'm by no means saying that this is a perfectly designed Snake game. At some point I just said, okay, never mind, let me just drop this, make this video, and I'll leave it to you guys to hopefully improve upon this game and make it even better. Or rather, I should say, improve upon this code and make this code base even more modular and elegant. That would be fantastic. So if you do have comments, please do shoot those in the comments, or if you do fork off from this code base and make changes, please do post your changes in the comments. That would be really interesting to read. But anyways, when we focus on modularity, we can, again, trivially achieve this kind of thing where we have one implementation for the terminal and one implementation for the web, which, of course, if we generalize this notion, what we're talking about here is that you might have a single core and then multiple different implementers of that core or users of that core. So that might mean that you could have, let's say, a multiplayer portion of your game, or you might expose your game through an API, or you might make an iOS version and an Android version and a web version of your game and so forth. And now I'm saying game, but actually we're talking about applications, right? So generally what I usually want to talk about is design of programs, is how we keep programs alive over longer periods of time, and how to increase modularity. And so in some sense then this game is just an example of that. But anyways, you could also just see this as how to build Snake using functional programming in JavaScript. Let's get going. So let me cancel out of the game here and let me make this full screen. Okay, so again, let me just show you the files that I have in this folder here. So the main Snake implementation is in this file called snake.js. That's sort of the core library, or the game engine in some sense. And then these three files, web.css, web.html, and web.js, that's essentially the web interface for the Snake game. So that's what we were looking at when we were playing in the browser, those three files. And then this CLI.js file, that's the Node implementation. That's what we were looking at up here, right? That's the terminal GUI through which you can play this Snake game. And then finally, this base.js is some base functions. So essentially, when doing functional programming, as I've talked about in other videos, we tend to pass data last, and we tend to have functions that are curried. So we tend to have functions that are partially applicable. But of course, JavaScript doesn't work this way, so that's why I implemented a few functions myself, such as map and etc. And of course, like if you would build an extensive game, you would probably use a third-party library, such as, for example, Ramda.js or another library implementing the Fantasyland specification. But for the sake of this video, I really wanted to keep everything self-contained. I don't want to use any third-party libraries, and this is why we have some code in this base file. But and then of course we have this README file, just because I've put this up on GitHub. And by the way, you can find the link to all of the code in the description. I might have moved it elsewhere, but the link in the description should work. Let's actually start by looking at the web end. So let's start with web.html. So let me open Vim, and then let's open web.html. And as you can see, I mean, this is clearly just any old normal HTML file where we are loading in the style sheet. Here I'm doing some funky stuff. I'll explain that in a moment. But then in the body, we have a canvas setup that's of a size 700 and of a height, or of a width 700 and of a height 500, and then I'm loading these script tags. And maybe people nowadays always load their scripts here and then make sure that the DOM is loaded in the scripts files. I was just lazy and put them here to ensure that when I load this web.js, the canvas has definitely loaded. But yeah, that's a completely different discussion. But anyways, you can see here that I'm loading in the base library, then I'm loading in Snake, and then I'm loading in web.js. So clearly, I mean, this is because I don't have a build system set up, or I don't have a build process set up. So I mean, clearly, if you were building this and actually shipping this on the web, you would probably somehow like minify all of your files into a single main.min.js file, right? And you'd only load that, and that would do everything. So you would construct a single JavaScript file from all of your other JavaScript files. But now this is just a simple example, so let's not bother with that, right? So then we're loading in the base library, and the base library will expose a bunch of globals, or it will essentially define a bunch of functions that are available on the global scope. And same thing for Snake, and then web is the actual machinery of this web implementation, or I shouldn't say the machinery, is the actual main entry point of this web application. And then let me just quickly explain this. I mean, this I do. Let me open up a split here and open up snake.js in order to show you that. So snake.js, because I started with the command line implementation. Actually, from the beginning, I was thinking that I only should do the command line implementation, but then I figured actually it's so easy to make another web implementation, so let me just make a web implementation as well. I'm a big fan of trying to keep it as absolutely simple as possible from the beginning, and this is why I started building this snake.js file, and I started doing it in a sort of step-by-step fashion where I implemented one function at a time, where it's like, okay, this function needs to be able to do this, right? So like if we have a list of snake points and we want to compute the next snake point given a movement in some direction, what would that function look like, right? And then I did that step by step for all of the different pieces, and then I sort of from the ground up built the Snake implementation. But anyways, because I did this, I want to make use of the module system in Node. So you can see here in the end that I say module.exports, and then I export a bunch of actually first constants and then 3 functions. And same thing goes for this base libraries. If we go to this base library here, you can see that this base library exports a bunch of functions. So clearly module.exports is not available in the browser. If you're in a similar scenario with some production code, you should of course look into something like Browserify, or maybe there's something more modern now. But now, I mean, we just do it. We can just hack it up. So I just simply said that in the global scope, I said that require is a function that returns an empty object. Right? And module is an empty object, and module.exports is also, sorry, so let me also say, I mean, I said require here, but I said that the problem in this right hand was the module exports, but actually we have, so in Snake, for example, Snake actually does require, right? So Snake, the Snake implementation or the Snake game engine depends on the base functions, the functions in the base library, the base library helper functions. So here we make use of the word require. So the browser does not have the word require, and the browser does not have the word module nor module.exports. And when I say word, I mean, of course, I mean keyword. Sorry. So anyways, we just say that require is a function that returns an empty object. Module, on the other hand, is an empty object, and module.exports is a function that returns an empty object. Just to make them not fail, right? They're not doing anything useful. And then I'm relying on the fact that I know that both Snake, base and Snake and web are all defining their functions like this, right? Here's a function, here are a few other functions, here are a few other functions, and so forth. So if I just run this code in the browser, they will be exposed as global functions. So just a quick and hacky way of getting this to work. But anyways, that's the web, right? So what it does, so you can think of this as that web is actually the entry point, or web.js is the entry point, and then web.js needs to first require base and then require Snake, and this is why they're in this order. Or actually, I mean, to be perfectly frank, rather, web needs to require Snake, and Snake needs to require base. That's actually the more proper way of saying it. So that's web HTML. Let's now look at web.js, right? So what does this actually do? So we don't have a ton of lines here, right? Let me just scroll through this file. You can see here at Yeah, 53 here I'm saying, I added a comment here to say that this is the main portion, right? So let's actually start from this main portion. So what web.js does, so the JavaScript that will be run in the browser when we run the browser version of the Snake game, right? First we do draw. So these are actually 2 lines, right? Sorry, I thought it was prettier to put them on a single line. So first we do draw, one initial draw. And then we say request animation frame. I don't actually really know what that is, but it's something like, well, the next time the browser will redraw using this function, please. Or something along those lines. So people who develop games tend to use these. So window.request animation frame, and then we pass the function step, or the function that's returned by invoking step with 0. And so importantly, usually people do this, right? They pass a function. But I'm actually invoking the function step because step, when invoked, will return a new function. And the reason for that is to avoid one global or another global. So step needs to keep track of how much time has passed since the last step, right? Because, so if I'm not mistaken, like, I mean, request animation frame might be called different times depending on the, I guess, frame rate or something like that of your browser, or the frame rate that you can manage to get on your browser. So like, depending on the performance of your computer, the request animation frame will be, or rather, the function that we pass to request animation frame will be called with different intervals, different time intervals, depending on the performance of the computer that you're running it on. So in every call to step, we need to check the delta. We need to check the diff between the current time and the last time we rendered. And that's why I passed this first variable, because here I'm saying then that, or this first 0, because I'm saying that the time since the last redraw was 0. So we're saying let's instantly redraw. So here you can see then that here's the definition of the step method, right? So the step method, or the step function, I should say, sorry, it takes a t1, so a time step 1, or timestamp, I should say, a timestamp 1 and a timestamp 2. And then it says, okay, what's the difference between timestamp 2 and timestamp 1? And if that's greater than 100, and I don't really know, let's think about this. So I can't really remember, but I assume this is in milliseconds. So that would mean 100 milliseconds, right? So a tenth of a second. So every tenth of a second, we enter this portion, and all of the other times we enter this portion. And now you can see how this works, right? Because if we do enter this portion, if 100 milliseconds has passed since the last time we updated, or the last time we stepped, then what we want to do is we want to say this state, this global state variable, I'll get to this in a moment, equals the next state given the current state, right? This is kind of typical functional programming, right? Instead of doing mutation, we're just saying that we have this global state variable. Global, well, I mean, you shouldn't have a global state variable, but I mean, in this case, it happens to be global. But essentially, the point is containing your state into a single variable and then passing that state through a function that produces the next state, right, from that given state. So instead of saying, well, here's my state, here are the actions that I want to do, let's change all of the variables so that it matches the new state, because then some things are more difficult to reason about because we have mutation all over the place. Instead, we say, well, here's the old state, let me pass you that. And then if you compute what the next state would look like given that old state, well, then I know what to do with that, right? So that's what we're saying. State is this state variable, and we say next is a function from the Snake engine, and when we pass state to that, it will compute the next state, and then we will set the state here, this mutable state here, to this new state, and then we will do draw. Right? And draw, I haven't even bothered about trying to make immutable in any kind of sense, because like the Canvas libraries, or the Canvas APIs of browsers are like there's tons of mutations, so that would be extremely painful. Maybe there's a way to do that. If you have an idea of how to do that, please do shoot something in the comment. That would be, or in the comment section, that would be very interesting to read about. Anyways, so that's for the if branch, or for the true case, right? For the false case, what happens? Well, in the false case, or in other words, when enough time hasn't passed, when 100 milliseconds hasn't passed since the last time we updated, then we simply do, my camera is in the way, I can see, but we simply do the same thing, or we say, or rather I should say, we don't compute the new state and we don't redraw, importantly, but we do request another animation frame, and to that we tack on, or we throw in a function that says step, again, from T1. So notice the difference between this line and this line, right? In this line, we have T2, and in this line, we have T1. T2 and T1. And T2 here is because we want to have the new point, the current timestamp as the next timestamp that we want to compare against. So like as the next timestamp that we want to say has 100 milliseconds passed from this timestamp, right? That's what we want to do when we do redraw. But when we don't redraw, we want to compute from the old timestamp. We want to say, well, you started at timestamp 0 and now 50 has passed. 50 is not enough, so keep on waiting, but you should compare against 0 and not against 50, because if we keep updating this, if we keep changing this to T2 here, if I said T2 here, we would never redraw, right? Or maybe in the odd case if it's super laggy or something like that, right? But assuming we have good frame rate, then we would essentially never call this, and then that'd be problematic. So this is why we're saying T1. And of course, I mean, maybe this wasn't clear, but what request animation frame does is that it passes a timestamp, and that is this T2 then. And I don't actually know. I mean, it's not like it's a date because we start from 0, but maybe it's something like the time since this browser session was initiated or something like this. I mean, since the page was rendered, I should maybe say. But anyways, I mean, I have no idea, so don't take my word for that. But that's the update method. But actually, let's go up to the top here, because I feel like what I didn't say is this, that the state variable that we talked about is defined here. So note this comment that says mutable state. So this is the state variable that contains the state of the game at all times. And it's global quotation marks, like it's shared across all of these functions in this file. And what you can do is that the functions, or actually the functions don't, there are two functions that change it, I should say, right? There's the step method that changes it, but there's also this key events thing, like there's this listener for key events, and that thing also changes the state, right? So actually let's look at that at once, right? Or wait, first let's begin here in the top. So we can say, okay, so we say let state is equal to the initial state. And where does this initial state function comes from? I mean, this is the problem of working with globals. It's very difficult to see where things are actually coming from since they're not actually scoped. I'm realizing now maybe I should have scoped them so that instead of making these functions all functions in this file, I could have put them inside an object, and that would give us a namespace here so that we could say snake.initialState, because that's kind of actually what we're looking at here. Like if you would use required, you would get that for free. But anyways, yeah, I should have fixed that, maybe. Yeah. But anyways, that's from the snake.js file. So snake.js file has a function called next here, right? And we'll talk about this when we get to the snake.js file. But suffice to say for now that the next function takes a state and computes the next state given that state. Oh, sorry, I was about to talk about initial state and not about next, but that's next, right? That's what next does. But if we look at initial state, that's just a function. It's I think it's called a unit function, like it's a constant in some sense. So it's a function that takes no arguments, so it's nullary, and it returns an object that is essentially a state representation, but it's the initial state. So the initial state is essentially always the same. So when you start a game, you need to start from the initial state. So yeah, that's the way we invoke this state variable. Now let's go back down here and let's now talk about these events. So we say window dot, so now my camera is really in the way, add event listener key down. So that's the first argument, and then the second argument is this function that takes a single argument, which is this variable named e, which is the event. And then we can extract the key variable or the key property from that event, and then we switch case over essentially that variable. And then we say, okay, well, we want to be able to control the snake using WASD, the keys, and HJKL. So here's WASD and here's HJKL, but then we also want to be able to use the arrow keys, right? So, and depending on which one of these we press, we want to compute a new state. We want to say that the new state is what the old state was, but plus, quotation marks, plus this new direction. So these are constants, north, west, south, east. These are constants that I've defined in this snake.js file, where we have north and south and east and west, right? And these are essentially just, I guess maybe you could think of them as vectors, I'm not really sure. But like they have an x direction and a y direction, or a velocity in these directions, right? So north means moving 0x, but -1y. That's the definition of north within the context of this game. But anyway, so we want to queue those in, and we need to pass the current state, because again, remember, the snake game has no clue of the current state that we have, right? It's actually, I should say this, it's pure, except for that the snake.js file has some randomness, right? So here we have one function that does some random stuff. And I mean, remember, randomness is impure because it relies on things such as system date and etc. So given the same input, you won't get the same output. But I mean, I was pragmatic here. I was just thinking like, there's no point trying to do something more complex here. In my mind, it makes sense for a function that computes a random position within a grid to be within the snake.js file and not elsewhere. But anyways, there are clearly solutions for that, but I'm just being pragmatic. But essentially, so then the snake enqueue method needs to be passed the current state. We need to pass the current state as we do here, right? And we need to do that because, as we do here, because again, it's almost pure, so it doesn't know what state we have. It doesn't keep track of its own state. And enqueue is also defined here in this snake method. And again, we'll get to this when we start to talk about the snake stuff. But essentially, as you can see here, it takes the current state and it takes a move. It asks whether the move is valid. And if the move is valid, it does this. If it's not, it does that, right? So if it's not valid, it just returns the same state. It does no changes. But if it is valid, then it says, well, okay, we want to merge. Yeah, we want to compute a new state that is the old state, plus that this moves property has changed to the old moves concatenated with an array containing only this new move. So this was an extremely complicated way of just saying append, but immutably append the last move to the list of moves. But we haven't even talked about the state tree, so we'll get to that in more detail. But that's enqueue, and this is sort of the basic game loop, right? Like if you think about this game, first from the main here, we draw one initial time, and that's sort of the first drawing. But then we say, well, start stepping from 0, and then we keep doing this step method. Okay, step and step and step and step and so forth. And whenever it's been 100 milliseconds since the last step, we compute the next state from the old state, and then we redraw, and then again we just keep on looping, quotation marks, keep on requesting animation frames. So that's sort of update and draw. But then there's also this other exogenous force that can enter, right? That like there are also key events. So like when the user types keys, we listen to this, and if you happen to type a key that's one of the arrow keys, then we need to compute a new state. So then we're also saying, well, you need to set the new state to the old state plus this new key that's being pressed. So I would say that's fairly clear. Again, like the benefits of mutation, or the benefits of avoiding immutation, is that whenever you want to change things, usually it's pretty easy to change things because you don't have to think about state. So for example, I'm not sure if you noticed, but when we played this game, well, sorry, of course, how could you have noticed? It's not actually visible. I didn't think about that. But the way the game worked from the beginning was that if I'm traveling in the direction west, as I'm doing now, and I press east, right? I'm traveling leftwards, but if I press the opposite direction, if I press east, right? Or conversely, if I'm traveling to the right and I press the left key, so if I press the inverse direction or the opposite direction of the direction I'm traveling in, I would instantly crash because it's like the snake is moving in this direction, right? And it's like it's immediately just going directly into its own tail, right? And some Snake games actually did work this way and was extremely frustrating. And that's what I noticed here as well. Like when I was playing this, it just messed me up all the time because I kept on crashing when I wanted to try out the game. So I figured, okay, let's actually remove that functionality from my Snake game. And that's when I added this valid move portion to enqueue. So previously enqueue used to only do this, right? It used to only just merge in whatever motion you added into the queue of motions or into the queue of moves. But now I said, well, actually, let's avoid this sort of inverse situation. So if you pass the inverse, so that's what valid move does. It checks whether it's the inverse. And if it's not the inverse, yes, then it's valid. But if not, if it is an inverse, then we will ignore it and we'll just pass the old state. So we'll not queue the move, right? So it's these kind of scenarios that we often find ourselves in when we use immutability. Like when we realize, okay, it would be cool if the game could do this, or actually this is a tricky thing. Let's not actually make it do this. Let's make it do that instead, right? And then we try it out, and it actually turns out to be fairly simple most of the time. But anyways, okay. So this is the web portion, right? We have the step function, we have the event listeners, we have, here in the main, let me just put that back on one line. We have this main that initiates it, and then we haven't talked about what draw actually does, right? So as you can see here, it's the comment says game loop draw, right? So this function draw, and it's also pretty simple. Like as you can see from the comments here, like I was contemplating separating this into multiple functions. But given the mutable nature of the canvas library and like given the fact that we probably won't reuse this code, I just figured whatever, let's actually just make this a long function that does all of these things like one by one. So what it does is that it clears the canvas, right? So ctx here is another global variable because what to do, right? So let's actually start from the top, right? So the first line says, okay, let's make a constant variable called canvas, and let's from the document get the canvas or let's get the thing that has the ID canvas. So if we look at the HTML thing, you can see that the canvas here actually has an ID of canvas, just to make it simple for myself, right? So I grab that canvas, and then we get the context for that so that we can draw. So in CTX is a context variable. Then we have these position helpers here. We'll talk about these in a moment. But what we do then is that we first clear this canvas by saying, okay, let's set the fill style to this like blackish color, I guess, and then we draw a rectangle over the whole width and the height. Then the next step is that we draw the snake, right? So then we say, let's set the fill style to something which is greenish, and then let's map over the snake. So this is where it sort of gets interesting, right? Because it's like the different graphics engines or the different GUIs or the different sort of interfaces can have completely different ways of interacting with this state, right? But so the state exposes .snake. It exposes actually lots of things like moves and apple and so forth and so forth. But we're just going to make use of snake and of apple. So what we do is just that we map a function over state.snake, and so snake is an array of positions. So it's an array of points being objects that have x and y coordinates. And of course, this is not an actual proper map because I don't care about the return result. So this is actually more like a for each that actually mutates the canvas. But map was a shorter word, so whatever. And in each of these iterations of the function, what we do is that we say, well, using this fill style, fill a rectangle in the context from this x position, this y position, over this width, and over this height. And now you can see why these x and y methods. And these x and y methods are just helpers for me so that I'm not duplicating the same math all over this place. So if you remember, what we did was that we drew rectangles, right? So notice how the snake, so every point in the snake or every piece of the snake, or just think of the apples, for example, take up sort of one quotation marks pixel, and pixel meaning like traversable pixel in this grid. Maybe I should say tile, actually, like it covers one tile. And so what we do then here is that we compute the position of these tiles. So x1 here will return the width of one tile, and y1 here will return the width of one tile. And what happens when we do this, y of some position, is that if the y coordinate is 0, then it'll turn to 0, right? Because if we look at the implementation of y here, we say take the canvas height and divide it by the number of rows that we have in the state. So like if the, sorry, I forgot to say that we have the r here as well, right? So if r is 0, r being the y coordinate, right? So let's say that the y coordinate is 0, and then we multiply that with the height of the canvas, and let's say that the height of the canvas is 100, and then we divide that by, let's say, 20, which is the number of rows, let's say, so the number of tiles in the y direction. Now this is not necessarily correct in regards to this particular scenario, but just hypothetically it makes sense. Then you can see that we get 0, right? Because that's a 0th position, like that's the pixel that we actually want to draw from. But if we take 1, we get 5. If we take 2, we get 10, and so forth. And if we take 20, we get 100, because like that's the last pixel. And actually 20 doesn't exist if we have 20. It's 19 would be the last one, because its height will also be 5, and then 5 will take it up to 100. But anyway, so those are just two helpers in order to not have to duplicate that. As you can see, we use these x and y things here as well. So that's the way we draw the snake. And then we do that for the apple as well. So we say, okay, here we don't have to actually iterate. We just say fill rect at this x position, at this y position, using this width and this height, right? And the width and the height is the same because the apple is as large as a tile, just as all of the pieces of the snake is as large as a tile. But the position is based on the x position of the apple, right? So the x position and the y position. So we're saying compute the y position from this coordinate, which is defined by state.apple.y. And then finally, we draw the crash. So let's just think about, so let's just look at that, right? Like if I crash into my own tail, notice how the screen flashes quickly red, right? Or quickly flashes in red. There you go, right? It quickly flashes in red. And how we know that that has happened is that I decided that, well, if we don't have a snake in the game field, that means that either the game has just started or there was a crash. So actually, if we just refresh the page, you can see that it blinks red. And maybe this is an unwanted feature and we should try to solve this, but I just figured, whatever, let's just not think about that now. So if there is no snake, right? So essentially then we're saying that if state.snake.length is equal to 0, so if we don't have a snake, then we should essentially draw this red rectangle over the whole screen, right? So that's the way we're indicating a crash. And that's the whole drawing thing. And I mean, a moment to pause and reflect, right? Like the point here is that this is all graphics, right? Like assuming that we can use this state structure for all of the graphics engines, assuming that state tree gives enough information, this can be completely focused on just the visuals, right? And is not sort of intermingled with all of the business logic. So if we say, actually, let's change the color of the snake, it's trivial to find the place where we can change the color of the snake. Or let's make the apples round. It's trivial to find the place where we make the apples round instead. And we don't have to worry about accidentally messing up some of the other core business logic because that's in a completely different place. So we have to be really silly in order to mess that up. So anyways, that's the draw. That's the draw function. And I think actually we've covered all of the stuff here then, right? Like first we just grab out the canvas, we set up this mutable state that's based on the initial state. We construct these two position helpers that will make us position things in this grid or a visual grid in the browser. And then we construct this draw function that will take the mutable state or based on the mutable state draw a bunch of stuff on the canvas. And then we have this game loop that whenever it's called checks whether it has passed enough time in order to progress to the next state and redraw, or whether it should just keep on ticking. And then we have these listeners that listen for events or listen for keystrokes and produce new states based on these keystrokes, where the new states contain the new keystrokes or contain the directions that we want to move in. And then finally we have this main that sort of just initiates and starts the whole thing up. And of course, I mean, we didn't actually need this first draw here in the end, right? Like the only difference if we have that, or if we remove that, you can see that there's a quick flash of 100 milliseconds where we don't have a board. That's essentially the only difference, and that's why I added that, because then immediately we should get the board. Actually, now that I think about it, it's almost hardly visible. I mean, like you can see, I mean, loading the page probably takes quite some time anyway. So yeah, I mean, you might want to remove that. Okay, but that's the web portion. Let's now actually look at the Snake core library. I think it's probably easier to start with that and then look at the command line implementation. So let's go to snake.js.